From the clothes we wear to the phones in our pockets, mass manufacturing shapes our world. It's the engine behind everyday products, making them affordable and accessible. This revolution in production touches every corner of the globe. We'll journey into this hidden world, uncovering the secrets behind the scenes. Get ready to explore the factories and innovations that define our modern age. Imagine a world without mass production. Cars would be a luxury for the super rich. Clothing would be hand-stitched, expensive, and rare. Electronics? A dream for most. Mass manufacturing changed all that. It democratized consumption, putting products within reach for millions. This shift from handcrafted to mass-produced goods reshaped societies and economies. The scale of this transformation is staggering. Our journey begins with a look at the industries revolutionized by mass manufacturing. First up, the automotive industry, where the assembly line transformed car production forever. We'll delve into the world of robotic arms and automated systems. Next, we'll explore the world of fast fashion. From cotton fields to clothing racks, discover how technology churns out trendy garments at lightning speed. The electronics industry provides our final stop. Smartphones, laptops, and gadgets dominate our lives. We'll uncover the precision engineering and global networks behind these pocket-sized marvels. Each sector reveals unique processes and technologies, all driven by the need for efficiency and scale. But it's not just about the what, it's about the how. We'll examine the intricate processes, materials, and innovations driving this mass production engine. From the raw materials to the finished products, we'll trace the journey of creation. Get ready for a behind-the-scenes look at industries that touch your life every single day. Mass manufacturing isn't just about replicating the same product endlessly. It's a hotbed of innovation, constantly pushing the boundaries of what's possible. We'll examine the cutting-edge technologies driving this progress. Robotics, artificial intelligence, and 3D printing are just a glimpse into the future of production. These advancements aren't just changing how we make things, they're changing what we can make. Customization, once a luxury, is becoming increasingly accessible. Imagine a world where your shoes are designed and manufactured specifically for your feet, all thanks to the power of mass customization. This is the future unfolding before our eyes. Mass manufacturing's impact extends far beyond the factory floor. It's a driving force in the global economy, creating jobs and connecting nations. But it also presents challenges. We'll explore the environmental impact and ethical considerations surrounding mass production. Join us as we explore the past, present, and future of this manufacturing marvel. Our journey into the heart of mass manufacturing begins with a marvel of engineering and efficiency, the automobile. Before Henry Ford's revolutionary assembly line, cars were a luxury, handcrafted for the wealthy. Ford's vision was simple: make cars affordable for the average person. But how could he possibly achieve such a feat? The answer lay in reimagining the very process of production. Ford's stroke of genius was the moving assembly line, a concept borrowed from the meatpacking industry. Instead of skilled craftsmen assembling an entire car, each worker specialized in a single, repetitive task. Parts moved down the line, each worker adding their piece to the puzzle. This streamlined process dramatically reduced production time and costs. The impact was nothing short of revolutionary. The Ford Model T, once a luxury, became attainable for the masses. This shift from handcrafted to mass-produced vehicles transformed America, putting the nation on wheels and forever changing the landscape of transportation. The assembly line, Ford's brainchild, became a symbol of industrial might, heralding a new era of mass production. Fast forward to the 21st century, and the automotive industry is a symphony of automation and precision. Step inside a modern car factory and you'll be greeted by a ballet of robotic arms, welding, painting, and assembling vehicles with tireless efficiency. These aren't your grandfather's robots. These are highly sophisticated machines, guided by lasers and computers, performing intricate tasks with superhuman precision. One of the most striking sights is the robotic welding process. Sparks fly as robotic arms move with balletic grace, fusing metal parts with pinpoint accuracy. These robots work tirelessly 24/7, ensuring every weld is flawless. The speed and consistency of robotic welding are unmatched by human hands. further accelerating the production process. But robots aren't just welders, they're painters, assemblers, and even quality control inspectors. Robotic arms equipped with cameras and sensors scan for imperfections, ensuring each vehicle meets the highest standards. The integration of robotics has not only increased efficiency, but has also improved worker safety by handling dangerous and repetitive tasks. The modern automobile is a testament to globalization, a complex tapestry woven from parts sourced worldwide. Engines from Japan, transmissions from Germany, electronics from South Korea, all converging on assembly plants scattered across the globe. This intricate web of suppliers and manufacturers highlights the interconnected nature of mass production in the 21st century. Logistics play a crucial role in this global dance. Just-in-time manufacturing, a system pioneered by Toyota, ensures that parts arrive at the factory precisely when needed, minimizing storage costs and maximizing efficiency. This intricate ballet of shipping containers, cargo planes, and trucks ensures a steady flow of components, keeping the production line humming. This globalized approach to manufacturing has its downsides. Disruptions in one part of the world, such as natural disasters or political instability, can ripple through the entire supply chain, causing delays and shortages. The automotive industry's reliance on globalization highlights both the benefits and vulnerabilities of interconnectedness in the age of mass production. Our exploration of mass manufacturing now takes us from the roar of car factories to the rhythmic hum of sewing machines into the world of textiles. This is where raw materials like cotton, wool, and synthetics are transformed into the fabrics that clothe the world. It's a journey that starts in vast fields, travels through bustling factories, and ends up on the shelves of your favorite stores. Imagine a sea of cotton, white as snow, stretching as far as the eye can see. These fluffy bolls, once harvested, embark on a remarkable transformation. They're cleaned, spun into yarn, and then woven or knitted into fabrics of varying textures and weights. From the simplest cotton tee to the most elaborate silk gown, it all begins with these fundamental processes. The scale of textile production is staggering. Giant looms, some spanning the width of a football field, churn out miles of fabric every day. These industrial behemoths are a testament to human ingenuity, capable of weaving intricate patterns and designs with astonishing speed and precision. It's a mesmerizing spectacle, watching raw fibers transformed into the building blocks of our wardrobes. No discussion of textile manufacturing would be complete without addressing the elephant in the room: fast fashion. This phenomenon, fueled by our insatiable appetite for the latest trends, has revolutionized the industry, compressing production cycles and making fashion more accessible than ever before. But this accessibility comes at a cost. Fast fashion thrives on speed. Trends observed on runways and social media are rapidly translated into designs, manufactured at breakneck speed, and shipped to stores worldwide. This rapid turnover allows consumers to refresh their wardrobes constantly, but it also leads to a culture of disposability, with garments often discarded after just a few wears. The rise of fast fashion has also shifted manufacturing to developing countries, where labor costs are lower. While this has created jobs in these regions, it has also raised concerns about worker exploitation and unsafe working conditions in some factories. The true cost of a cheap t-shirt is often hidden from view, obscured by the allure of affordability. Despite the challenges posed by fast fashion, the textile industry is also witnessing a wave of innovation and a growing awareness of sustainability. New technologies are emerging, promising to reduce the environmental impact of textile production and create a more ethical and sustainable fashion future. One such innovation is 3D knitting, a process that creates seamless garments directly from digital designs, minimizing waste and allowing for greater customization. Imagine ordering a sweater online and having it knitted to your exact measurements, with no fabric scraps left behind. This technology has the potential to revolutionize how we produce and consume clothing. Another promising development is the use of recycled materials. Plastic bottles are being transformed into polyester yarn, and discarded clothing is finding new life as raw material for new garments. These innovations, driven by both environmental concerns and consumer demand, offer a glimpse into a future where fashion is less about fleeting trends and more about conscious consumption. Our exploration of mass manufacturing now takes us into the clean rooms and bustling factories where silicon dreams become reality. From the sleek smartphones in our pockets to the powerful laptops we rely on, electronics manufacturing is a marvel of precision engineering and global collaboration. This is where raw materials like silicon, gold, and rare earth elements are transformed into the devices that connect us, entertain us, and power our modern lives. Imagine stepping into a vast, sterile environment where workers in full-body suits meticulously assemble tiny components. This is the world of semiconductor fabrication, where silicon wafers, thinner than a human hair, are etched with billions of transistors using light and chemicals. These microscopic circuits are the brains of our devices, processing information at lightning speed. The scale of electronics manufacturing is mind-boggling. Factories churn out millions of smartphones, tablets, and computers every year, each one a testament to the intricate dance of automation and human skill. Automated assembly lines, guided by lasers and cameras, place components with micron-level precision, while skilled technicians monitor the process, ensuring every device meets the highest standards. From the silicon heart of a processor to the glass of a touchscreen, assembling an electronic device is a symphony of intricate processes. Once the individual components are manufactured, they embark on a journey across the factory floor, passing through a series of automated and manual assembly stations. Each step in this intricate dance is crucial, ensuring the final product functions flawlessly. One of the most mesmerizing sights is the surface mount technology, or SMT process. Here, tiny components like resistors, capacitors, and integrated circuits are placed onto printed circuit boards with incredible speed and accuracy. Automated pick-and-place machines, guided by cameras and sophisticated software, rapidly pick up components from reels and place them onto the boards, ready for soldering. Soldering, the process of melting a metal alloy to create a permanent electrical connection, is another crucial step. While some soldering is still done by hand, particularly for delicate components, wave soldering machines have revolutionized the process. These machines pass circuit boards over a wave of molten solder, creating hundreds of connections simultaneously, ensuring the integrity of the electronic pathways. The journey of an electronic device doesn't end on the factory floor. Once assembled, these gadgets embark on a global odyssey, traveling by sea, air, and land to reach consumers worldwide. The logistics involve a complex web of warehouses, shipping companies, and retailers. Imagine a cargo ship, longer than the Empire State Building is tall, carrying millions of smartphones. Upon arrival at ports, containers are unloaded, sorted, and loaded onto trucks. Cargo planes loaded with the latest gadgets crisscross the globe. This intricate dance of ships, planes, trucks, and trains highlights the interconnected nature of our global economy. From car factories to electronics assembly, mass manufacturing shapes our world. It's behind our cars, clothes, and gadgets. This drive for efficiency and affordability touches every aspect of our lives. That t-shirt you love? It started as raw cotton, spun, woven, and printed before reaching you. Mass manufacturing brings undeniable benefits, but it often hides a human cost. Exploitation and unsafe conditions are prevalent in developing countries. Environmental impacts like pollution and resource consumption are significant. Discarded electronics pose ecological threats. However, ethical and sustainable practices are on the rise. Consumers are choosing responsibly produced goods, supporting a better future. Looking ahead, the future of mass manufacturing is ripe with both challenges and opportunities. The rise of automation, driven by advancements in robotics and artificial intelligence, has the potential to further increase efficiency and reduce labor costs. However, this also raises concerns about job displacement and the need for retraining programs to equip workers with the skills needed in an automated future. One of the most exciting frontiers in manufacturing is the rise of 3D printing, also known as additive manufacturing. This revolutionary technology has the potential to disrupt traditional manufacturing models, allowing for on-demand production, customized designs, and decentralized production facilities. Imagine a future where you can download the blueprint for a new gadget and print it at home, using locally sourced materials. Mass manufacturing, once synonymous with mass production, is evolving to embrace customization and personalization. Advances in digital manufacturing and data analytics allow companies to tailor products to individual customer preferences, blurring the lines between mass production and bespoke craftsmanship. This shift towards mass customization has the potential to usher in a new era of consumer goods, where products are not only more personalized, but also more sustainable, thanks to reduced waste and more efficient production processes.